Today we're going to continue our work in Chapter 9, Chemical Reactions. We are focusing on learning goal number 2. The students will be able to predict products of a chemical reaction. All of this information can be found in section 9.2 of your text, Classifying Chemical Reactions. Hopefully you remember that there are 5 types of chemical reactions. We spent yesterday's lesson looking at reaction type number 1, synthesis reactions, where there is only one product or one substance on the right side of the arrow. We also took a look at combustion reactions, where oxygen has to be one of the reactants. Today we're going to focus on reaction type number 3, decomposition reactions. A decomposition reaction is a reaction in which a single compound breaks down into 2 or more elements, compounds, or both. Again, a single compound, one substance on the left side of the arrow, one reactant, breaks down into 2 or more elements, compounds, or both. Let's take a look at the example decomposition reactions. In the first reaction, substance AB breaks down into 2 simpler substances, the elements that compose AB, elements A plus B. Again, we know that this is a decomposition reaction because there is only one reactant. If we look at the second reaction, also a decomposition reaction, the substance sodium oxide, the only reactant, breaks down to form the 2 elements that compose sodium oxide, the elements sodium and oxygen. A decomposition reaction often requires an energy source, such as heat, light, or electricity to occur. So when writing and balancing these types of equations, we need to remember to add a triangle over the arrow. Sometimes that triangle will be replaced with light or electricity, but we need to add some form of energy in order to get the reaction going. Let's fix the 2 reactions above and make them correct by adding the triangle over the arrow. Let's take a look at predicting products for decomposition reactions. It says here that we can check the gold sheet to help with our products. In problem A, we are looking at the heating of lead-2 oxide, and we need to predict who the products are going to be. Let's check the backside of our gold sheet regarding decomposition reactions to see if it will help. Problem A was the heating of lead-2 oxide. If we take a look at the list of rules for decomposition reactions, we can see that that would fall under category 6 for decomposition reactions, decomposition of a metallic oxide. And it will tell us who the products need to be. Metallic oxides, such as lead-2 oxide, lead being the metal, oxygen being the oxide, will break into its elements when heated. Those 2 elements being the elements lead and oxygen. Let's finish the word equation. Heating lead-2 oxide yields lead plus oxygen. The only thing left to do is write out and balance the equation. Lead-2 oxide, we've got to balance the charges. 2 plus and 2 minus, it's a match made in heaven. It's going to be a solid, as most ionic compounds are. We need to add our energy because it's a decomposition reaction. And it yields the element lead, a metal, and a solid, plus oxygen gas, a diatomic. To balance the equation, we need to have 2 oxygens in the reactants, which also changes our lead. And there we're balanced. And again, we know that this is a decomposition reaction because there is only one reactant. Let's take a look at the second example problem. Example problem B. Decomposition of magnesium hydroxide. Let's check the gold sheet, the back side of the gold sheet, to figure out what the products are going to be. So we're looking at the decomposition of magnesium hydroxide. That would fall under Rule 2 for decomposition reactions. Metallic hydroxides, such as magnesium hydroxide, magnesium being the metal attached to the hydroxide, would decompose to form metallic oxides and water. The metallic oxide would be magnesium oxide plus water. Let's go back to the problem. Decomposition of magnesium hydroxide would yield a metallic oxide, magnesium oxide, plus water. Let's write out and balance the equation. Magnesium hydroxide, we need to balance our charges. 2 plus, 1 minus, you need parentheses. It would be a solid, as most ionic compounds are, is going to decompose to form a metallic oxide, magnesium being the metal, attached to oxygen, 2 plus, 2 minus, a match made in heaven, plus water. Let's go ahead and make sure the equation is balanced. We've got 1 magnesium in the reactants, 1 in the products, 2 oxygens, 2 oxygens, 2 hydrogens in the reactants, and 2 hydrogens in the products. The equation's balanced. Again, we know that this is a decomposition reaction because there is 1 reactant. Let's move on to example problem C. In example problem C, we have decomposition of barium carbonate. Let's check the gold sheet to see who the predicted products are for this reaction. Decomposition of barium carbonate. A match made in heaven. And where would that fall on our list of rules? And I believe we would be dealing with Rule 1. Metallic carbonates form metallic oxides and carbon dioxide when heated. Let's go back to the problem. So decomposition of barium carbonate would yield a metallic oxide. That would be barium oxide, barium is the metal, plus carbon dioxide. Let's go ahead and write out and balance the equation. Barium carbonate, let's balance our charges. 2 plus, 2 minus, match made in heaven. It would be a solid, as most ionic compounds are. We would have to add heat, and that would form a metallic oxide, barium oxide, 2 plus, 2 minus, match made in heaven, plus carbon dioxide gas. Get rid of our charges. If we take a look, we can notice that the equation is already balanced. 1 barium, 1 barium, 1 carbon, 1 carbon, 3 oxygens, 3 oxygens. And again, we know this is a decomposition reaction because there is only 1 reactant. Let's move on to example problem D, electrolysis of water. This is a little bit different. The word electrolysis means that electricity is the energy that is added. We won't add a heat sign, over the arrow. We will add electricity. Let's check the gold sheet to see who the predicted products are. Electrolysis of water. Water would fit under rule number 4. Some binary compounds decompose into elements by electric current. So electrolysis of water would yield the elements that make up the binary compound. Hydrogen plus oxygen. Let's write out and balance the equation. So we've got water, which would be a liquid. We would run electricity through. We would form hydrogen, a diatomic, plus oxygen, also a diatomic. Let's balance the equation. We need 2 oxygens, which is going to change us to 4 hydrogens over here. It's balanced. Again, decomposition reaction, because we only have one single reactant, one thing on the left side of the arrow. Let's take a look at the last problem, heating potassium chlorate. Let's check our gold sheet. We are heating potassium chlorate. We can see that potassium chlorate would be a metallic chlorate, potassium being the metal combined with chlorate. They would form metallic chlorides and oxygen when heated. Metallic chlorates form metallic chlorides and oxygen when heated. So, heating potassium chlorate would yield a metallic chloride, potassium chloride, plus oxygen. Let's write out and balance the equation. Potassium chlorate, 1 plus and 1 minus, would yield potassium chloride, one plus, 1 minus, plus oxygen gas. Add a triangle over the arrow, and all we need to do is balance the equation. The oxygens are not balanced. We need to get them to 6. And a 2 in front of the potassium chloride. The equation's balanced. Again, a decomposition reaction because there is only one reactant, one thing on the left side of the arrow.